Hi there, welcome to www.highschoolmaths.co.uk. Today we're going to be looking at how to find the length of an arc and the area of a sector. So we're going to start off, we're going to have a look at a couple of questions on how you find the length of an arc and the area of a sector. And then we're going to look at some problem solving questions involving those two topics. So we're going to start off with this question here, find the length of an arc. We've got an arc or a section of a circle here cut out with an angle of 38 degrees at the center and 7 centimeters for the radius from the middle of the circle to the outside. So we're looking at kind of finding the circumference, which is this curved line at the outside of the shape. So if I just highlight that here, this is the line we're looking for. Okay, so when we're dealing with the question, we'll calculate the length of the arc shown. We're looking for just this curved piece, the kind of archway. Now, the formula for arc length is quite straightforward, providing you know your circumference formula, because we're talking about the outside edge of a circle, which is the circumference. But it's not a full circle, it's a fraction of a circle. So the arc length, this yellow part I've just highlighted, is going to be the angle over 360. So it's going to be the fraction of the pie chart, x out of 360, times pi d, because c equals pi d. Once we know our formula, and you do have to memorize that, once we know our formula, x is our angle, so for this particular arc, we've got an angle of 38 degrees over 360, so that's the fraction of the circle that we've got. 38 out of 360. For a full circle, we'd have a 360 degree turn, times pi, times the diameter. Now, already mentioned, 7 is the radius, that's the middle of the circle at this point here. So 7 is the radius, the diameter would be 14 centimeters. And then you can just type that into your calculator. So it's 38 divided by 360 times pi times 14. And that should give you 4.64 centimeters. And we'll round it to 2 decimal places here. Now, that's part one. Part two, then going on to ask us what's the perimeter. Now, the perimeter is the length around the outside of any shape. So here we're looking at this sector of a circle. We know that this yellow part that I've highlighted here is 4.64. That's what we just found out. So that yellow part is 4.64. However, we've now got to find the perimeter of the whole shape, which is all the way around. So we've got to add on these two straight lines, or the two straight edges. So we can see that this one's 7, and this one's also going to be 7 because that's from the middle of the circle to the outside, so that's the radius as well. So our perimeter would be 4.64 plus 7 plus 7. And if we type that into our calculator, or we can do that one quickly in our head, we get 18.64 centimeters. And again, that's just 2 decimal places because of our previous answer. Okay, so that's how you find the length of an arc. Finding the area of a sector is very, very similar. So let's have a look at an example on that. Finding the area of a sector, you can see the formula looks really, really similar to what we had for arc length, but instead of having pi d, we've got pi r squared. Okay, so we've got a different sector of a circle here, and our formula is angle over 360, so it's 30 in this case, over 360, that's the fraction of the circle that we have, times pi times the radius squared. So the radius of the circle is 6 centimeters this time, from the middle to the outside. So we're using the radius this time, so it's times 6 squared. Type that into your calculator, 30 divided by 360 times pi times 6 squared, and that gives you 9.42. Again, we'll just keep the round into 2 decimal places just now. So cm squared or squared centimeters for our answer there. And there's no other working required there. We're just asking for the area, so the space inside this 2-dimensional shape. So the area of the sector is 9.42 square centimeters. Okay, so that's your kind of working forward, working there. When you're looking at problem solving type questions, and they can come in a variety of different approaches, but I'll try and cover 2 examples here using arc length or sector area. So here we have an arc length of 10 centimeters. Okay, so the arc has an arc length of 10 centimeters. So this part here is 10 centimeters. Okay, so this black line here that I've just annotated as 10 centimeters. This part here is 14. and we're looking for the angle at the center of the section. So we're looking for this angle in here. Okay, my diagram is obviously not particularly to scale, but it's just a sketch to give you an idea of what's going on. Okay, so the key thing here is looking at what you've got. Okay, we want to find x, so it's different from what we had before. Okay, but the information we're being given is that we know the arc length. Oops. So we know that the arc length, oh, what is going on here? We know that the arc length is 10 centimeters. So if it tells us that information, that means we need to use the arc length formula. Again, you need to memorize that. So it's x over 360 times pi d for your arc length. We then have to fill in any information we know. In this case, we actually know the left-hand side of the equation. We know that the arc length is 10 centimeters. So I'm going to put the 10 on the left-hand side for our arc length. The angle, this time, we don't know. So it's x over 360 still, times pi times the diameter. Now the diameter would be double the radius. So from here to here, that's the radius from the middle to the outside. So the diameter would be 28. Now what we've got to do is we've got to rearrange this equation so that we can find the value of x. And you'll find with all these questions, it works in a really, really similar way. So we're going to move everything over at once. I tend to find that's the easiest way to do it. So we're going to multiply both sides by 360, first of all. And at the same time, we're also going to divide by pi times 28. Okay, so we're going to take this pi times 28. That's multiplied by pi times 28. We're going to divide by pi times 28. And that just leaves us with the x on the right-hand side. Okay, so we've kind of changed the subject so that the x, which is what we want, is on its own. Now we just have to type this fraction into the calculator. If you've got a dual line display, great, you can just type that in as it looks. If you've not, then if you just type in the top line in a bracket and the bottom line in a bracket, that will work totally fine as well. So let's type that in and see what we get. Pi times 28, close the bracket, and that gives us 40.93 degrees. Okay, so 40.93 degrees. I've rounded to two decimal places there, probably an angle. If we're talking about an angle, one decimal place would be fine. But again, look at the question, see if it, double check to see if it asks you for any particular rounding in the question, just to make sure after you've completed. Okay, so our angle there is 40.93 degrees, which seems reasonable. So we'll finish that off there for that one. And again, we can cover another similar example for sector area. So we've got a sector here, and we're told that the area of that sector is 8 centimeters, 8 square centimeters. We're told that the radius is 4. So we're looking for the angle again at the center. So I'll call this y this time. Okay, and here, because we're given the sector area, we're using the sector area formula. So it's angle over 360 times pi r squared. And we've got to substitute in all the information we already know. So the sector area was 8. That's what we're told here. The angle we don't know. So it's x over 360 times pi times the radius squared. The radius is going to be 4 from the middle to the outside. So it's times 4 squared. And you'll see this time, from the previous example we did, you'll see how similar the rearrangement is. So if we take the 360, we multiply both sides by 360, so it's 8 times 360 on this side. And also, if we divide both sides at the same time by pi times 4 squared, we end up with the x. Oh, sorry, it should have been y value. I've gone through with x there. Let's change them to y's. So we'll say, because we're working with y this time, I like my x's a lot, so that's why I use x quite a lot. Okay, so we've got y degrees on there now. So our value for y in this case is going to be 8 times 360 divided by pi times 4 squared. And look how similar that looks to the previous working. If we flick back a page, look at the similarity there with the rearrangement. It's pretty much exactly the same format. Okay, so you're just balancing out that equation, and it looks the same regardless of its sector area or arc length. Okay, and then if we type that into the calculator, again, top line, if you're not using the kind of dual line display, make sure you put a top line in the bracket. So 8 times 360 in a bracket, then divide that by, open up a new bracket, and pi times 4 squared, or pi times 16 if you prefer. And I do. And that gives us 57.295. So we'll say 57.3. There. You could put 57.30. That's entirely up to you. So I'll just put 57.3 and we'll round to one decimal place for this one. So our value for y was 57.3. Again, my sketch isn't particularly drawn to scale. It's just a sketch to give an indication of what's going on in the question. And that's a really good tactic to use in a problem solving type question if it comes up in a test or an exam. Okay, so that's been arcs and sectors. There's loads and loads of varieties of different questions that come up in different contexts. So you'll see other ones that are non-calculator, other ones that have different kinds of diagrams or are mixed together with kind of volume or area questions or areas of different shapes, compound shapes. There's lots of variations. So it's just practice as much as you can. But these are your kind of basic skills that you need to at least get started with your core questions on arcs and sectors. So hopefully you found that useful. For other maths videos and resources, please visit www.highschoolmaths.co.uk. And if you liked the video, don't forget to click that like button and subscribe. And please remember and share the video. Thanks for watching and have a mathemagical day.